This is CS50, and this is week 1, our second week. And today, recall that we'll focus on this other programming language called C. And we gave you a little glimpse of this last time, wherein I proposed that this code here on the screen is something that you will soon know how to program, if not already. But suffice it to say, it looks quite a bit dissimilar to what we looked at last week, which, of course, was Scratch, which was much more playful, much more graphical. And so allow me to disclaim right from the get-go today that for most of us, today will feel like a bit of a fire hose. In fact, pictured here is an old hack from MIT, wherein some industrious seniors hooked up an actual fire hydrant to a water fountain. The saying being that getting an education from MIT is like drinking from a fire hydrant. Today will feel a little bit like that, because this is sort of a special occasion that you don't really have occasion to describe very often, but it's one in which we're all going to learn a new language. And indeed, that's not something we do every day. And so at the first glance, it's going to look like a lot of new syntax, a lot of new ideas. And yet, allow me to reassure that what will soon look like this C code here, is fundamentally the same thing that you've seen and now experimented with last week by way of Scratch. That is to say, within this other programming language, C, which is more traditional, which is more text-based, more keyboard-based, we're still going to see functions, conditions, Boolean expressions, loops, and so on. They're going to all look a little different, but the ideas are the same. And so much like when walking into someone's home for the very first time and getting the lay of the land and seeing a lot of things that you haven't seen before, you typically don't care about all of those visual details. You might just simply walk forward and sit down. Similarly, today, we're about to see a whole lot of details in the world of this programming language, but the goal at hand is to ignore things at first glance that we don't necessarily understand and latch onto those ideas that are familiar from last week. So how do we go about actually writing computer programs? How do we go about writing them well? And so allow me to propose that there's a few guiding lights that should guide writing of code. One, of course, is correctness. And we explored this last week, whereby the correctness of your code just speaks to, does it work as intended? When you double click some icon, when you run some command, does the program that you or someone else wrote behave correctly? Does it do what it says? But there's other aspects to writing good software and writing good programs, and that has to do with design. And we alluded a little bit to this last week, but with design, it's more of a qualitative, a more subjective measure, just how well written your code is. So imagine, for instance, from taking a class where you have to write essays. You could certainly make very correct arguments, but you could make very correct arguments by writing very long, rambling sentences, repeating yourself, and generally not writing a very good essay or paper. Now, it might be correct. There's nothing in that paper for your English class, history class, or whatever it may be that you said that was incorrect, but you might not get very good marks on it because it's just not very well designed. And so similarly in the programming world, is there this notion of actually writing not only correct code, but well-designed code, wherein you don't repeat yourself. You write code that's fairly efficient. It doesn't do more work than it actually needs to. And then lastly, let me propose for today onward in this class that there's a third axis you should keep in mind when it comes to writing good code, and that has to do with style. This is much more of an aesthetic. So this, in the analogous world of writing an essay, would be, are you using good punctuation, capitalization? Are you indenting new paragraphs? And those kinds of aesthetics that fundamentally don't change the correctness of what you're saying, don't change necessarily the quality of the arguments that you're making, but the style of your essay, much like the style of your code, makes your code much, much more readable. So when it comes to writing good code, you want it first and foremost to be correct, but also well designed and also well styled, much like, again, you would when writing an essay that you would hope would reflect well on your capabilities as well. So when it comes to writing code like this, for instance, this first C program that someone last week proposed quite simply prints out on the screen hello world. Well, how do we go about writing this code? Last week, we wrote code by going to scratch.mit.edu and then dragging and dropping puzzle pieces. Today's going to be a little different. We're going to use a different tool here on out. And we're going to use our keyboard much more than our mouse to actually program. But to do so, we're going to go ahead and introduce the first of several tools this semester, this one known as CS50 IDE. IDE is an acronym, a term of art in programming that stands for Integrated Development Environment, which is just a fancy way of saying in this context that CS50 IDE is CS50's own web-based programming environment. And it's not specific to CS50 per se. We've simply added a number of educationally useful features on top of a third-party cloud tool that anyone on the internet can use. And our own version thereof lives at this URL, ide.cs50.io. So you're welcome to follow along at that URL today, but you need not during lecture itself. But on this upcoming problem set and beyond, will you actually use and get more familiar with this tool hands-on. So let me go ahead and open up this tool here. So I've already logged in advance. And what you see here is the basic user interface that's available to you. And fortunately, there's only a couple of salient features that we need point out right now. So at the top of this screen here is just a big black rectangle that in a moment is going to be filled with code, much like using Google Documents or something like that, where you can create new tabs and create new files. This is where I'm going to do my programming along the top of the screen. And along the bottom is what we're in a moment going to start calling our terminal window. It's in this terminal window that I can actually run commands and ultimately run my actual code. But let's go ahead and write our very first program in this environment and realize that this tool indeed is not very CS50 specific. It's meant to be representative of a very common, popular programming environment where you have a so-called text editor or tabbed windows where you can write code, and a terminal window where you can actually run commands. Ours happens to exist in the cloud, but you can alternatively program certainly on your own Mac or PC or any other device these days. But frankly, it tends to involve just a non-trivial number of technical difficulties early on, especially when we all have different versions of Mac OS and Windows and the like. So this cloud-based environment just ensures that on day 0, we can all have the same exact programming experience. So I'm going to go ahead and do this. I'm going to go ahead and go up to File and New File. And this is going to create a new tab, by default called Untitled1. Not very interesting. So I'm going to now go up to File and Save. And by default, I'm going to save this file as, for instance, the name hello.c. So I want to write my very first program in this language called C. I'm going to call my file hello, but I'm going to end it in a file extension called .c. And that's indeed the convention. When writing C programs, they should end with .c, just like Scratch programs, as you may recall, end in .sb3. So I'm going to go ahead and simply click the green button here that's called Save. Nothing is really going to change except for the name and the tab there. Now I see at top left that this tab is called hello.c. And now I can start typing anything I want. And frankly, I'm just going to type from memory the very first program we saw last week and just a moment ago. I'm going to do include standardIO.h, whatever that is for now. I'm then going to do int main void, whatever that is for now. I'm going to use a curly brace and then close that curly brace, so to speak, thereafter. And